Okay, so now we're going to start to implement the calculate functions in Android. So we've implemented all the functions to choose the calculations. Now we're going to start implementing the actual calculate functions themselves. So we're going to implement just the first of them that will perform the actual calculation, and I want you to think about after this video how we're going to do the rest of them. We're also going to implement some helper functions that will pass the data that we input as a user, and will also print the results out. Alright, so now you've seen one being implemented, let's implement the other four. Okay, so again these are the choose and then the variable and then calculation. So what we're going to do, this is going to be the initial velocity, and we're going to create another switch statement. So I'm just going to copy this all and I'm going to paste it in. And we're going to check for the check against the calculation. So we need to add one more case this time. That's going to be the first case, and that's going to be the calculation that we left out. So I believe that was this one. Just going to go ahead and select it, and that's this. And in this case we're going to combine strings equals set hints, and let's take a look at which hints we should be setting. Okay, so we're choosing the initial velocity, so vi shouldn't appear in any of them. So in this case, we know vi, but we don't know vi, but we know a, t, and d. So what we're going to do is we're going to set these hints to be a, we're going to set them to be d, and t. Okay, so again, we're just setting the hints to be the ones that we don't know. So this time we know, again, we don't know vi, but we know vf, a, and d. So we can just change this to a VF, and isn't copying and pasting so much faster. And again, in this case we know VF, A, and T, so we're going to change that to VF. And in this case VF, T, and D, so VF, D, T. Okay, so that's good, and I guess we should include the break there. So I'm going to save that, and I'm just going to copy this over again, and this should be the initial velocity this time. Okay, and again, just going to copy this and paste it here. So again, we're using calculation, acceleration. There's going to be one of these that doesn't have acceleration. That's going to be this one. Just going to take that out and going to change this to acceleration. Okay, so now in this case, we know VI, we know T and D. So we're going to change this to VI and D and T. In this case, we know VF, VI, and D. So this one should be VI. And in this case, we know VF, VI, and T. So VF, VI, and T. So that can be saved. And we're going to go ahead and paste that again. This time we're not calculating the initial velocity, we're doing the displacement. And we have, let's see, what do we know from here? We don't know displacement, but we know VI, A, and T. So it should be VI, A, and T. And the reason I'm keeping VI and VF at the beginning will become clear towards the end. I'm just trying to keep things as much in this order as possible. Okay, so the order in which we have it, and you'll see why towards the end. It will become apparent. Okay, so which of these calculations doesn't have displacement? That's this one, so I'm going to take it out. And then we're going to say, so we know VF, VI, and A. So VF, VI, and A. And in this case, we know VF, VI, and T. So VF, VI, and T. Okay, and now on to the last one. Let's calculate displacement there. The last one is going to be, which one don't we need? We don't need this one because it has no time in it. And this one's really complicated to rearrange, so I'm not even going to bother with that one. So we're going to set the hints to VI, VF, VI, and so this one's going to be A. And this last one, VF, VI, and D this time. Okay, so just going to save it. So we've got these calculations all set up, and basically they're going to set the hints to be the proper variables that we know. It's going to store this variable combine strings and pass it into the appropriate calculate acceleration or calculate initial velocity function. Let's take a look at those now. Before we do these, however, we'll need to take in some inputs. So if we go back to main.axml, you remember we have these three fields. So these are going to be user inputs, and the user is going to input three variables. And that's going to be these three here. In each case, they're a little different. But we're going to need to handle those. So basically what we're going to have to do is we're going to have to handle or create a function to handle the input. And I'm just going to call this avoid pass variables. Okay, so it's not going to take anything in. It's just going to assign variable 1 to be whatever, we're going to have to pass whatever the text is to a double. So you should have seen this function before by now if you watched some of our videos. I know this is a pretty complicated video for your first one, so hopefully you've seen some of the more simple ones. But basically we're just taking the text from the first input, changing it to a double and storing it in variable 2. And that's what we're going to do for each of these. So field 2 text.text. And we're going to do it for the last one too, variable 3 equals double.pass. And we're going to take in field 3 text.text. Okay, so that's all this function is doing, is it's taking in the inputs and storing them in variables 1, 2, and 3. So to save it. And now what we're going to do is we are going to initialize these functions here. And that's going to be these 5 here. So I'm going to do in fact, I'll just do them all in one go because I think it should be pretty quick once we get the hang of it. So the first step is going to be to pass the variables. And then we're going to say if we're going to create these conditions. So if the variables equals, and that's why we have this combined strings being returned, so that we can just take in these variables. So which ones would be missing? Let's say vi, a, and d. So this is what combined strings would be, which is why we're taking this string of variables. And if that's the case, then we'll do something. We'll perform this calculation. So final answer is going to be some sort of manipulation. So this one is going to be, we're going to have to call the power function. And then we're going to have to call the power function again. Math.pow, and then it's going to take in variable 1, which is going to be the vi, and it's going to square it. And then we're going to add 2 to it, or it's going to be add 2 times variable 2 times variable 3 and then that's all going to be raised to the power of 0.5. Okay, so I know this is a bit complicated, but basically what I'm doing is I'm taking these 4 equations and I'm mixing them up. So I'm basically just rearranging them to expose the variable we want. So in this case, in that last case, I was using this calculation where I just had this equation and I took the square root of this to get VF. In this case, we have vi and t, so that's an easy one. This time we'll have to do some rearranging, so it would be 2d divided by t minus vi. Okay, so in fact, once we get this first one ready, so where did I put that z? Okay, there we go. So I'll get the first one ready, and then I'll implement one other little helper function that we'll need, and then I'll get you to think about how the other ones are going to be implemented. Okay. So we have the first case, and now we need to create a second case and a third case. Okay, so the second case is going to be where the variables are vi, a, and t, and if that's the case, then final answer, it should be double equals there. Final answer should be equal to variable 1 plus variable 2 times variable 3. Okay, and the very last one will be if variables equals vid and t, then our final answer should be equal to 2 times variable 2 divided by, not dot compare to, divided by variable 3, and it's going to enclose that in brackets, minus variable 1. Okay, so again, I know this is, and then we're going to do a couple other things. So first we're going to scroll up to the top and we're going to create this variable called units. It's going to be a string units, and this will just help with the print statement. So it just kind of makes things look a little nicer. So we're just going to set the units here. This is a final velocity, so units will be in meters per second. And we're going to call this function print results. And that's the one I'm going to implement now. So if we scroll to the very bottom, we're going to call a print results. And this one's going to be a pretty simple function. All it's going to do is it's going to say the answer text.text is equal to final answer dot toString plus the space plus whatever units is. So it's basically just taking in the final answer, which is going to be a doubles, converting it to a string, it's adding a space, and then it's going to add units onto the end of it, and it's going to display it in the answer text, which is going to be down here. Okay, so that's all going to be done once the button is pressed, and in fact we should add the handler for that in the calculate final velocity function, and I'm going to do that now. So this is going to be when the calculate button, which I believe did we implement that? Yep, should be calculate button. So calculate button dot click. So when the calculate button is clicked, plus equals delegate, it should do all these things. So none of this stuff should happen until the calculate button is pressed, and that's what this line is saying. Once calculate button's clicked, do all of this, okay? But not before. Okay, so now we've implemented the first one. I know I went through it a bit fast, but this is just kind of manipulating the equations. So what I want you to do now is to pause, and I want you to figure out all the different manipulations of these equations to expose the necessary variables. And that's basically what the last part is going to be before we design the layout. Okay, so think about that, and we'll be right back. Okay, so in this part of our tutorial, we started to implement the calculate functions in Android. So we implemented just the first of these functions that will perform the actual calculations. That was a final velocity one. And we had a couple of helper functions, so one to parse the data and one to print out the results. So now I want you to think about how the rest of these calculate functions are going to look, and before you do that I want you to pause and I want you to figure out all the ways that we can manipulate the equations to expose the variables, because there are quite a lot of them, and that's what's really going to take up the bulk of the time in this tutorial.